obscure corner of the universe, situated on a backwater arm of an unremarkable galaxy called the Milky Way, a fistful of planets wend their way around a rather standard issue star. But take a closer look at the third planet out, and there it is. A restless blue planet with a red and violent soul.
One, two, three, four, five. 5 pennies? Man, this thing is expensive. I spent like $20 on this and now I'm left with only 5 pennies. And even worse, they're made out of copper. If these pennies were made out of gold, I could have sold them at the market. But they're made out of copper. I hate copper, and I also hate pennies too.
Wait a second, my friend. You know how much these pennies are worth?
Yeah, 5 cents.
I know they're not worth a lot financially, but you know what are these pennies made up of?
Yeah, they're made out of copper. Copper is useless.
Copper is not useless. You know how much we use it in our daily lives? And we use it in a lot of things.
Yeah, right. I bet they only use it for pennies, nothing else.
Oh man. You need to know a lot about copper, my friend. So, you want to know?
Sure, but I bet there's nothing else they're used for.
Okay, so I think I need to tell you more. So let's go on a journey in the past, when copper was first discovered.
Copper is a metal that's created when volcanoes erupt. As magma makes its way through cracks in the Earth's crust, deposits of copper ores take birth. Copper was first discovered in the Middle East on an island named Cyprus that is located in the Mediterranean Sea. The Romans were the first civilization to discover and mine copper. They mined deposits of native copper, which is copper metal that is not bound up in any compound. This pure form of copper was very easy to work and did not need refining.
So now you know more about copper than you did before. Am I right?
Yeah, I learned many things that I didn't know before.
That's good. Do you want to learn more?
Yeah, sure.
Okay, so copper reacts with many things. And this reaction process, the reaction stuff is kind of scientific. You sure you want to know that?
Yeah, I want to know some reactions.
Okay, So, have you ever heard about any copper reactions? Anything copper reacting with anything?
Well, now that you mention it, is it true that copper reacts with oxygen?
That's so true. You're on the right path. Copper reacts with oxygen. So when it comes in contact with oxygen, over time it oxidizes. The scientific term, oxidizes. So when it comes in contact with oxygen, the oxidization process starts. And it kind of starts to turn like greenish, kind of blackish, greenish, more greenish. You'll see more green most of the time. It's even kind of bluish. Have you ever seen that?
Well, I haven't really noticed it.
Okay, you know the Statue of Liberty?
Yeah?
It has copper traces in it. And it's kind of turning green. You want to go see that?
Yeah, let's go see.
Okay. Now you know that copper reacts with oxygen and it kind of turns green. And I would have told you more about reactions, but right now I have to go and attend a chemistry class in my university.
Okay.
So we may meet again and then I'll tell you more. Okay?
Okay.
I'm sorry.
Okay.
Okay.
Thank
Bye.
you for teaching me.
Okay.
Bye.
Oh, you know what? Wait a second.
Yeah?
I think my professor today is going to talk about metals. That's so cool. Maybe he's going to do an experiment. That's what he was telling me that day. Yeah, he's going to do an experiment with copper reacting to nitric acid. And that's what you want to know. Reactions, right?
Yeah.
Okay, then you want to come with me?
Sure, let's go.
Okay, let's go. Whoa.
This is 50% nitric acid, and you can see right away something's happening. You can see some bubbles coming out of this. Long live the Queen. You can see a few things. I don't know if you can see the color, but there's a lot of greenish coloration coming off of this, and that's the copper ion going into solution. Whenever you see a blue-green sort of aqua color in solution, there are probably copper ions in it. The other thing you can see are the bubbles coming out, so you've got to explain that as well. And this is a redox reaction. Whenever a metal dissolves in a liquid, there is undoubtedly a redox reaction going on because the metal is being oxidized. It's going from pure metal, valence of 0, to copper ions. Those are the blue things. I don't know if you can see any blue color now. Uh-oh. And this toxic brown gas is coming out the top here. Slow that down a little bit. So what's going on? How come the copper is dissolving and what's that brown gas coming off the top? Well, you have to explain it in terms of something being oxidized and something being reduced. So you've got to split this reaction into two so-called half reactions, one showing the oxidation with the release of electrons, and the other showing a reduction which will take in those electrons and reduce something. So the copper gets oxidized. This one's easy because we know that blue ions in solution mean copper plus 2 ions. So copper goes to Cu plus 2, and you've got to balance this thing so there's a couple of electrons being released. This is why I say dissolution of metals like rusting of your car first, where the metal becomes metal ions, and then obviously it's not much use to you. It's not going to hold your car together anymore. The only thing in there where the metal becomes metal ions, and then obviously it's not much use to you. It's not going to hold your car together anymore. The only thing in there which is easily reducible is the nitrate ion. And the nitrate is part of the nitric acid. Again, you're going to have to come to recognize this as being a soluble compound, so HNO3 is actually hydrogen ions and nitrate ions. The nitrate ions plus the hydrogen ions pick up the 2 electrons from the oxidation and become N2O4 plus water. So it's the nitrate that gets reduced and it becomes dinitrogen tetroxide, which is also present as 2 NO2s, and it's that which is the, boy, this thing's really going now. Oh, might as well show it to you. Oops, you can't even see it's active. So that penny will be gone momentarily, I would say. It's probably, yeah, it's getting pretty thin. I'd say she never looked better, actually. I'm not a monarchist, as you can see. So the nitrate gets reduced to N2O4. And as we'll see next time, there's an easy way of balancing these reactions.